This very well could be the clearest sign of life that we've ever found on Mars.
Okay, John, the big question is, are we going to find life this time on Mars?
Could strange Martian rocks hold fossil whispers of life, or just geology's clever illusion? NASA's Perseverance rover has uncovered mysterious minerals and textures in Martian rocks that may be the fingerprints of ancient microbes. Curious? Let's dive into the evidence hidden inside Jezero Crater's mudstones. Signs of ancient life on Mars. Imagine standing at the edge of a vast, dried-up lake on Mars, looking at rocks that have not been touched for over 3 billion years. Now imagine a rover, no bigger than a car, slowly drilling into those rocks, its instruments peering deep into their ancient secrets. This isn't a science fiction setup, it's real. NASA's Perseverance rover, exploring Jezero Crater, has uncovered minerals and textures in mudstone that scientists say could be signs of long-vanished microbial life. Yes, you heard that right. We may be staring at the first genuine hints that life once flickered on the red planet. But before you jump out of your chair, let's explore what Perseverance really found, what it means, and why scientists are buzzing with both excitement and caution. What exactly did Perseverance find in Jezero Crater? In July 2024, Perseverance drilled into a fine-grained reddish mudstone at a site nicknamed Chayava Falls, inside the Bright Angel Formation, an area that used to be part of an ancient river delta. The rock core, named Sapphire Canyon, turned out to be loaded with fascinating features. Its minerals include clay-rich smectites, carbonates, iron oxides like hematite, and most intriguingly, vivianite, iron phosphate, and greigite, iron sulfide. On Earth, these last two often appear in wet, low-oxygen environments where microbes are busy altering chemistry. Add to that the detection of organic carbon, plus strange leopard spot and poppy seed textures in the rock, and suddenly the case for ancient habitability looks stronger than ever. Think about it, you've got water-rich clays to preserve life, chemical energy sources microbes could have exploited, and even the organic building blocks themselves. If you were designing a Martian laboratory for early life, this rock might be your blueprint. Minerals that whisper about life. Now, let's pause and think, like planetary detectives. Why are scientists intrigued by vivianite and greigite? These minerals often form on Earth where bacteria thrive, such as swamps, lake beds, and oxygen-poor sediments. For instance, greigite appears when sulfate-reducing bacteria get to work, while vivianite crystallizes in organic-rich muds. Spot these minerals in Martian rocks and your brain jumps to, could microbes have been here too? But there's a catch. Mars is not Earth. These minerals can also form without life through purely chemical reactions. The excitement is real, but so is caution. Scientists walk a fine line, eager to embrace potential biosignatures, but careful not to shout life before the evidence is rock solid. And here's where it gets thrilling. Perseverance is caching these samples for a future Mars sample return mission, meaning one day we may hold these potential biosignatures in labs on Earth. The strange beauty of leopard spots. If you saw the rover's images of these rocks, you might notice something bizarre. Dark spots and halos peppering the surface, like leopard skin. They are tiny, about the size of sesame seeds, yet carry massive implications. On Earth, similar ringed features sometimes emerge when microbial mats trap minerals or when organic material interacts with groundwater. Could these Martian spots be echoes of such processes, or are they simply the result of chemical weathering over billions of years? Here's where the story hooks you. Picture an ancient Martian lake bed, its waters calm and teeming with microscopic life. Over time, as the lake dried and sediments hardened, these little chemical footprints were frozen into stone. Fast forward to today, and a robot is showing them to us across 200 million kilometers of space. Whether or not they're biological, the drama of that narrative is breathtaking. Why this matters for you and me. At this point, you might be wondering, why should we, sitting here on Earth, care if microbes lived on Mars billions of years ago? Here's why. If life emerged independently on Mars, even at the microbial level, then life is probably not a cosmic accident. It could be common across the universe. Suddenly, those billions of stars with their billions of planets don't just seem like distant dots of light. They become potential homes. This discovery would reshape our understanding of biology, philosophy, and even spirituality. It's not just a Mars story, it's an us story. We're asking one of the oldest questions humans have ever pondered. Are we alone? And Perseverance, with its dusty wheels and laser-equipped eyes, is bringing us closer to an answer. Could it all be chemistry? Of course, science is about skepticism. For every exciting claim, there must be a sober counterpoint. Could all these minerals and textures be purely abiotic, the result of natural chemical reactions in an ancient lake bed? Absolutely. Mars has a history of complex geology, with volcanism, groundwater flows, and mineral alteration that could mimic biosignatures. Organic carbon doesn't automatically mean fossilized life. It could have been delivered by meteorites or formed through non-biological chemistry. That's why scientists insist on bringing the samples back to Earth. Only with advanced lab tools, isotope analysis, high-resolution imaging, and chemical fingerprinting can we tell if these rocks preserve faint whispers of microbes or just the artistry of geology. Still, think of the suspense. These cores are sealed in titanium tubes, quietly waiting for their return trip. It's like the universe has handed us a locked treasure chest, and we're itching for the key. The next steps in humanity's red planet journey. So where does this leave us? Perseverance has not proven life on Mars, but it has given us the strongest hints yet. In these rocks lies the best chance of finding ancient Martian life ever collected. Future missions, especially the ambitious Mars Sample Return program, will bring them back to Earth, where they'll be scrutinized down to the atom. In the meantime, Perseverance keeps roving, drilling, and discovering, while its cousin, the Ingenuity helicopter, has already shown us the power of flight on another world. Together, they remind us that exploration is not just about technology, it's about curiosity, persistence, and imagination. And that's where you come in. Each time we ask whether Mars once harbored life, we're also asking what it means to be human, to search, to wonder, and to never give up. Maybe, just maybe, those mudstones in Jezero Crater are whispering back across time, you are not alone. It could all be geology, or it could be the first whisper of Martian life. These samples are now sealed, waiting for their journey back to Earth. If you found this discovery exciting, make sure to like, share, and subscribe to stay with us as we uncover more mysteries from Mars.